In this problem, I've got a tire that has a temperature of -5 degrees Celsius on a cold day, and I fill it to a gauge pressure of 20 psi. What's the gauge pressure when the temperature rises? Okay, so I have like initial conditions and final conditions. So in this case, if I have a gas that's changing from initial to final, that's a combined gas law problem. So I'm saying PV over T equals PV over T, right? So that's P1 V1 over T1 equals P2 V2 over T2. So when you're using the combined gas law, anything that stays the same, I can take out of the equation, right? So because this tire is staying the same volume, I don't need the volume. So I can just say P1 over T1 equals P2 over T2. So I can solve this equation for P2, right? I'm going to solve for P2. So let's figure out what our pressures are. P1, T1, and T2. I need to get these. And then I can solve for P2. So P1 is going to be my initial pressure. So that's 20 psi. So it's 20 psi, but that's a gauge pressure. So gauge pressure means 0 is atmospheric pressure. So I need to add on the atmosphere. That's my atmosphere. So I'm going to add whatever my pressure was plus the atmosphere, which is 14.7. So that gives me 34.7 psi. Okay, T1, my initial temperature, right, that goes with P1, -5 Celsius. So -5 Celsius, I got to turn to Kelvin. Can't use the combined gas law with Celsius because you could have zeros, and zeros don't work out in this equation because you divide by 0 and everything blows up. So I have to add 273 to turn that to Kelvin. So that's 273 plus -5 is 268 kelvins, right? Okay, it's 971 is 273, yes. Okay, and then my T2, it rises to 20 degrees C. So 20 degrees C, again, I got to convert 273. 273 plus 20 is 293 Kelvin. And now I've got my 3, and I can plug in and I can solve for P2. So whenever I get P2, the question's asking for what's the gauge pressure. So whatever I get for P2 when I solve this equation, I need to tack back, I'm sorry, not tack on. I have to do P2 minus 14.7 to take me back to a gauge pressure, right? So I had to add 14.7 here to turn it into an absolute pressure. I'm going to get my absolute pressure here. In order to get gauge, I have to subtract the atmosphere, and that'll give me my P2, that's going to be P2 gauge pressure. And that's it, right? So it's just a combined gas law problem, but I had to do a couple conversions. Normally you don't have to do conversions in these problems, but you always have to turn Celsius to Kelvin. In this case, I had to go between gauge and absolute pressure.